Test, test. Hello? Alright. Test. Testing 1, 2, 3. Hope you guys can hear me. What's up? What's up? Gonna do some Leetcode in Python, array questions, some Leetcode easies, and then one Leetcode medium. Diet Coke, but I'm not sponsored by them. Let me start recording this. Hopefully my mic levels are okay. Let me test it actually before I start. All right, good. Sound quality sounds good. Shall we get to the problem at hand? All right. Remove duplicates from sorted array. Given an integer array nums, sorted in non-decreasing order. What is a non-decreasing order? First of all, you need to understand that. It means the numbers are either going down or the same. So non-decreasing is not the same as increasing because the numbers could be the same. Non-decreasing order, my bad, I meant the numbers can go up or be the same, but not decreasing. That's not a possible input. So when you read this problems, and this is in bold as well, so it's kind of like a hint for something, right? Remove duplicates in place such that each unique element appears only once. The relative order of an element should be kept the same. So they want you to return only unique elements. So what we can do is have a placeholder that will pretty much fill out the numbers that are only unique, and another index, left and right index, let's say, the right index will trace through all the numbers. So if we start the left index at 0, first of all, always got to check the constraints. So the list of nums will always be at least 1. So first thing we can check is if the size of our array is only 1, then what do they want us to return? Output 2. So they want us to return how many unique elements. So if it's 1 unique element, we'll return only 1. So if we start, let's take input and output, right? So we can picture this. So if we start our left index at 0, we know it's the first number, so it will be unique. And then our next index, right, could be the one that just goes through the whole list. And then we determine using right index and left index if the number is already there or not. Just checking, can you guys see the screen well? So, all right. Anyways, so in this example, right, let's say our left index is 0, right index of 1. So let me think. Technically, the first index is always going to be unique, right? So the right index, if it equals to 1 as well, then we just move on. And then if it's not, we can increase the left index and place that number there. So let's start with our right index. We can start with 1, and you want to go through the whole list, or in other languages, it's called array. So for basic example first, right? So in this case, we can compare, is our index at left index equal to the one at the right? I think it's better to compare that if they're not equal, because if they're not equal, we know we have a unique element and we can just move on, right? So for example, if it's not equal, we can just increase our left index by 1. And then we can place that new right index into the left index. Okay, that's if they're not equal. If they're equal, we don't really need to do anything, I don't think. Let me see. Say we'll return left index. So let's use this example. So we'll start left index at 0, right index we'll start at 1. Are they equal? 1 and 1. No, they're not. There are equal, so we skip that. Then we go to next right index, which is going to be a 2. Then we compare again. So let's say in this case, index still at left, and this one is at the right. So no, 2 and 1 are not equal, so we know we have a unique element. So using this code, we'll move the left index to the right, and then we'll place 2 right there. Boom. So at this point, we have 2 elements, so we need to return left index plus 1. Let's see if that works. I forgot to start the timer. Oh well. Boom. First problem down. So hopefully that made sense. What we did, we used the left index as our unique element tracker, and the right index to go through all the numbers and find the unique ones and compare to the one to the left. So what's the big O time here? It's going to be O, and N is number of elements in nums, because we need to go through all the numbers to see if they're unique or not. Space here is going to be, well, we're not using any space except left index and right index, and we're using the input they gave us to manipulate. We don't create any new input, a list, or any other data structure, so it's going to be O1. All right, we're going to go to the next problem, let me check if there's anything that chats. Great info. Thanks, Mr. Sandeep. That's great. How's Scottsdale, Arizona? I need to bring up the chat, I think. Let me see. Let me see if I can. That's the view outside my place from the balcony. That's the room right here. Boom. New spot, new live stream for Leetcode. All right, should I get to number 2 question? Or not yet? Be right back. Gonna use the restroom facilities, and I have food coming, but I'll get to the next problem after this. Be right back. All right. Let's see. All right, let's look at remove element number 27. Given an integer array nums and an integer val, remove all occurrences of val and nums in place. The order of elements may be changed. The return number of elements and nums which are not equal to val. Then return the number of elements. So basically, they want you to return the number of elements in this list that is not equal to the value that they pass. It's very similar to previous problem, except here, instead of duplicates, we're looking for numbers that are not equal to the value that they pass. So we can use left and right index here as well. So the first number might be the val that they're passing. could be like an edge case. So we can always start our left index from -1. And then if the first value is not the same as the value they passed, then we can increment left index and put the number there. But first, let's look at constraints. So the list might not have any numbers, right? So in that case, if it's empty, we'll just return 0. Because they want you to return first k elements which are not equal to val. So if the list is empty, there's no elements to return, all right? So we'll start a left index with -1. This will be the index that had the first index will be 0, which is going to be a number that's not equal to val. That's why we're going to start our traversal of the right index from 0, because we need to check if that number equals to val or not. So that index, num's right index, if it's not equal to value that they passed, then we know that's a correct number that we should count or place in our list. So what we can do is increment our left index by 1. So now the first time, let's say, if the value is not equal to whatever item is in the input. I'm a visual person, and I know a lot of people, when they hear explanations, they need to see it visually as well. So let me just paste it, some input here. So for example, in this example, they don't want us to include any numbers that are 3. So initially, our left index will start at -1, right? The right index starts at 0. So L is our index, right is our. All right, so if 2 is not equal to 3, that's a valid number. So what you can do is increment left by 1, like I'm doing here, and then we can place that number there. Pretty simple, right? Maybe that's why it's Leetcode easy. So let's say in this case, once we place let me just do my own version of this. So that's left and right, our indexes are there, right? So 3, basically, so 3 is not a valid number here, right? So index L is still going to be at -1. And then right index starting at 0, right? So in this input of 3, 2, 2, 3, when our index is at -1 and our right index 3, so this number is equal. So we won't go into this case, and then right will increase. So 2 is not equal, we'll go into this case, this condition, I mean, and then we'll copy the number. 2 is not equal to 3. Once again, increase this and copy it. Okay. So we'll need to return index as well here, because let's say we hit L2 right here, right? And everything else is a duplicate. Then we're at index 1, so we need to increase it just by 1 to give us the correct number of items. Because indexing starts with 0 now, computer science, right? So this code should work. Boom. Another problem solved. So let's analyze the runtime here. Big O, time. It's going to be number of items in the list nums. So on times space. We didn't use any space here besides variables. That's O1 time. Second problem done. I'm gonna check on my food really quick and then continue more problems. Oh yeah, my food is here. Be right back. One second. Boom. Be right back. Got myself a like 50 grams protein shake from Protein House. You know, when you do Leetcode, you use a lot of brain power. So you need protein, hydration, energy, caffeine, coffee, whatever works for you. Let's see. Yeah, this protein shake, Protein House, it's called Muscle Freak. The cast name, huh? Muscle Freak. Let me tell you the macros for it. So it has 619 calories, 56 grams of protein, 40 carbs, 28% of fat. Boom. Only get foods where you can track macros so you know what you're eating and putting in your body. Sandeep. right, I'm back. You guys ready for the next problem? Yeah, I'm just doing a bunch of list Leetcode easies right now. And then I'm gonna do final problem, medium one. Move to a new place, so testing out the stream as well. So far, so good. Everything is working. Set up different scenes. This is my room view. Boom. And we got the background view. And this is live, by the way. This is not. There's another camera outside on the balcony. This live stream. Let's see. All right. Let's start this problem. Leetcode 1929. Concatenation of array. All right. So given an array nums of a length n, you want to create a new array answer of length 2n. And the conditions are whatever element is in nums at index I, it should be also an answer index I, and in index I plus n. So basically, the answer array is going to be combination of nums twice the size. So what are the constraints? Yes, there's going to be at least one element always. So what we can do is get the length of nums, and then our answer array, we already know it's going to be twice the size. So we can just initialize it with zeros and twice the size of n. And then we can just go through the list of nums and place the answer in two spots where they asked, because they asked to place it in answer I and answer I plus n. So for example, so if our input is 3 here, our answer is going to be twice the size. So when we go through this nums here, initially we'll place, so let's say our index at nums 0 right here, right? Index I. So we'll want to place that here plus n, which is 3. So it'll be 0, 1, 2, 3. And we want to place the I here, right? So then when we go to the next location where I is at 1, this will move as well. So we'll place the 2 here. Then when we go to the last location, this will move as well. And then we'll just place 1, and that will be the final solution. Right? So you want to visualize the examples that they give you first before you start writing code and see if it makes sense. Because there's no point of writing code if you cannot even visualize how it's going to work, unless it's super simple. But this is pretty simple. It still helps to visualize. So then in this case, we'll just use our index to go through all the nums. So index in range. And all right, we already got the length. So all we're gonna do is answer at index will be the same as item at nums index. And here we also need to do plus n index. Now, what do they want us to return? Return answer. All right, okay. So we just gotta return that right now. Boom. Boom, there it is. So the time here, we need to go through the whole nums list. So all the elements. And then the space, we did create an answer which is double the size of our original list, nums, but that still just becomes and space, I guess. Yeah. So that's third problem of today. I'm gonna go finish my protein shake. And then I'll start on the last two problems. All right, 2 more problems, and I'm out. All right. Given a string. Okay, Leetcode number 20, valid parentheses. Given a string containing just the characters, determine if the input string is valid. An input string is valid if open brackets must be closed by the same type of brackets. So they must match. If this opens a bracket in a string, this must close it. Open brackets must be closed in the correct order, meaning this one opens, you cannot close it with this right one or this one. It has to be closed with this one. Every closed bracket has a corresponding open bracket of same type. So any closed bracket like this one, for example, or this one, it needs to have beforehand a corresponding open bracket, which makes sense. So this is output is true because you have opening and closing bracket of the same type. Same here. This is false. 2 opening brackets. This is true. So as long as the brackets are being opened and then closed properly, that's valid. See, in this case, different type of bracket closes this one, so that's false. Length 1. Length 1 automatically is incorrect because we need 2 brackets. So if length is 1, then we return false. So for this, the simplest way is to use a stack, because we want a stack of parentheses coming in if they're being opened, and then we can process them one by one with the closed ones. So for example, let's use a simple example. Now, how do they think of a stack? That's just from experience of solving problems when you're processing strings. If ideas don't start popping up to you when you see a problem, you just need to solve more problems. You all have to start somewhere. So in this case, we have a stack, right? And then, so what we want to do is let's process everything one by one, and we need to go through the whole string. So how will we know if we have an opening or closing string, right? So what we need to do is when we encounter this first string, first letter at the index, let's say 0, right? This is gonna be index 0. What we want to do is, if it's an opening, then we want to throw it on the stack, right? Because we need to buffer. Let's say this was like this, right? We need to buffer the opening parentheses, and then to see if we have the ones that are coming up, if they can close them or not. If they can, we just start popping from the stack. If not, that's false, right? So the easiest way, instead of writing like manually code to check every single parenthesis, we can create a hash map that will map the valid and invalid parentheses. So because we're gonna be putting the opening parentheses on the stack, and we'll use the closing parentheses as a way to check if there's a match on the stack, we'll use the closing parenthesis as the key. So it's easier to access the opening parentheses. So for example, if index is at 2, we need to quickly access and see what is the equivalent opening parentheses for this. And the way we do that is by checking the hash map, and it will return us the opening parenthesis, and then we can see if that's on the stack. Let me know if that makes sense to you. If not, I can explain more in comments or follow up, because this is real time right now, streaming. So this is a map of all the possible parentheses in the hash map. You know, we can give it a better name. It's a parentheses map. So as we're going through the index of the whole string, let me rename this also stack parenthesis. I don't like this name. P stack, all right? And then we'll just call this P map. Just shorter. So it's in the interviews, they do care about your variable names. So it's important to also name things in a way where the interviewer does not deduct points from you. Anyway, so as we're going through this, first we'll get the value from the string at the current index. Now, if this is one of the, so it's very important constraint here that says string only consists of parentheses. So we don't need to worry about non-parenthesis characters, because that could be a case as well. So it's very important to understand the constraints. So we have the value here. First, we need to check. So is that an opening parentheses? And how are we going to do that? If value is in P map, we can just extract values. So if that value, if that variable value exists in the hash map of values, not keys, then we know it's an opening parenthesis. So in that case, we'll throw it on the stack. Else, we know that if it's not in values, it must be a key. Now, like for example, if constraint was that there could be other key values except parentheses, we would need to do a check if that value is in keys as well. But here, we know this will be always opening parentheses. And this is the case for closed parentheses. Right. So if you get a closed parenthesis, then we need to check if we have a stack. Because if you have a closed parenthesis, we need an opening parenthesis, right? So if our stack is empty, then we don't have an opening parenthesis or any parentheses beforehand. The closed parentheses is the first thing that popped up. So that's false. That's not valid. So for example, this would happen, let's say, if we had a string that was like this. That would be the first variable, right? We would go into here because it's in not in values, it's in keys, and then the stack is 0, so we don't have an opening parenthesis. That's the case where it fails right away. Now, if we have a stack, now we need to check. We need to check. Is the value on top of the stack, does that match with the one in, does that open parenthesis matches with the current close parenthesis? So the way we can do that is basically we can access the stack, the last variable in the stack like this, but we can also, we can pop and then check if p stack, if the top variable in the stack should be an opening parenthesis that matches this close parenthesis. If it's not, then that's not a valid string. So if that variable at the top is not equal to our map, 1 second. Usually I like to, let me extract it first. So let's say top open parenthesis. So we'll do it like this. All right. So now to check if it's valid, we need to check the current value. So let's say let's go through our input case again. So we'll check here. What's going on here? 1 second. Oh. All right. So let's start. So for index and range, so index in the beginning is going to be 0. Our value is going to be this parenthesis right here. Right. And then, so is that value in map values? And yes, it is. It's right here. That's one of our values in the PMAP. So we'll append that value to our stack. So our stack here will have this, okay? So then when we go to the next index, our next value is going to be this, all right? Is that value is close parenthesis in our values? No, it's in our PMAP keys, not values. So we know it's a close parenthesis. Now, if the stack is empty, return false. Otherwise, let's extract the opening parenthesis, which is in this case, it's going to be this, all right? And then what we need to do is check if the current value, so if PMAP, because our current value right now is this, right? So we're accessing using this key, this close parenthesis, we're getting the value, which is this, right? So we need to check if those are equal. So is it equal to the top open parenthesis or not, okay? And if it is, it's all good. So we can just pop that stack and move on. Otherwise, we return false. And when we exit this loop, we need to also make sure that we don't just return true, because we need to know maybe the stack should be empty because we're popping it every time we find a valid parenthesis, right? I don't like this name. Let me rename parenthesis. Whatever. All right, something like that. All right. And then, so what I was saying is if we have values in our stack, that's not valid. That means we didn't process all the opening ones. So there's more opening parentheses than the closed ones. So we need to return true only if that p stack is equal to 0. Let's see, let's run it. There you go. It's actually a pretty good problem, pretty simple to solve, but to explain why PMAP is designed this way and how the parentheses openings and closing works, why we need to pop it and check the stack. That could be, I guess, tricky for someone that's just starting. So let's figure out the runtime here. So time, we need to go through all the values in our string. So number of letters, we need to run through all of that. Space, well, the worst case is if they're all opening parentheses, we'll have to push everything into the stack. So that will be on as well. Let's see, so yeah. So basically it's on because let's say we have a string that's like this. Right, we'll have using our code, we would go through and keep appending all those opening values to the stack. So in this case, we would have like 5 values in the stack. That's why it's spaces on in this case. All right, that's the fourth problem for today. And then we have one more problem I'm gonna do. So Leetcode medium. We've been doing easies, so we're gonna do medium as the final one. But I'm gonna take a quick break before that, so you guys can enjoy the Vegas view and some music for now. Game over. Who said it? Sivak. Let's see. All right, one more problem, and I'm gonna go wake up early, and I gotta do laundry as well. Uh-oh. Oops. Hold on, I think my browser froze. I'm trying to fix it. I don't know what's going on with my browser. Worst timing ever. But anyways, let's see. Can I? 1 second, I'm trying to fix my browser. All right, let's get into this problem. Design a stack that supports push, pop, top, and retrieving the minimum element in constant time. Implement the mean stack class. So they give us a bunch of methods, functions, methods to initialize the stack object, to push the element to the stack, to pop the stack, to get the top element of the stack, and retrieve minimum element in the stack at any time. And the catch here is every function must have O1 time complexity, so instant time. So we need to be able to get, no matter how many elements we have in the stack, the minimum element in O1 time. The way we can do this is when we push onto the stack, we can also push the most minimum element at that time along with the value. And then when we retrieve something from when we do pop and retrieve an element, let's say, if that was the minimum element, since we're storing the minimum element at every item, it will also disappear. So let's say we create a new stack here as a way to initialize the stack object, right? So we'll have a normal stack. So now when we push something under the stack, the way you can push it is by appending, but not just the value itself. We can also push the most minimum value, right? So let's say before we push, we need to know, is that the smallest element or not? So the way to do that is we'll use our getMin function here that we didn't implement it, but we're going to implement it, and we expect that that's going to return our most minimum value right now, right? And we need to compare that with the current value because it could be smaller than the minimum value we have now. And then when we push on the stack, we'll push that value and the most minimum value there is. So our stack will have always actual value and minimum element value. And then when we pop, we don't really care if we remove the minimum value because it will be also tracked in all the other items as well. So we can simply just do pop. And then to get the top element, we'll just return stack. We access the top value on the stack, or the last value on the stack we push by doing -1. And since we have two elements, as you can see here, value and minimum value, our actual element top will be a 0 index. And then same thing with get minimum, except our minimum value is at index 1 over here. And this should work. One second, something is wrong with my browser. I don't want to restart it right now as I'm testing this problem, but 1 second, let me see. Yeah, I cannot even access the browser right now. 1 second. All right, now it's working, it looks like. Oops. So let's copy this code Let's see if it works. Oh, list out of range. Let's see. Let's use this example. That's why in a real interview, you always want to run through an example of your code to catch the mistakes. Always trace through examples. All right, so let's see. So initialize means stack. Cool. And we push -2. Oh, yeah. So that's, see where I cut the mistake. We can only get minimum value from the stack if it exists, right? So that's where the edge case is. Because otherwise we're trying to access get min and there's nothing on the stack. So only call self get min if there's values in the stack. Then we'll get the min. Otherwise, min value is just going to be the current value. Or we can do this. So by default, we'll assign value as a minimum value. But if you have something in the stack, then we'll override it either with the value that already got passed, or if we find something more minimum. Boom, there it is. But yeah, that's a good example of how a simple edge case where we don't have anything on the stack, so it crashes, it acts as invalid index, can happen during the interviews. So you always, when you're solving, you want to run through an example first before telling your interviewer that it's done, whatever. You need to show them that it actually works. And sometimes you want more than one test case, certain edge cases and things like that. The interviewer wants to see your thinking process. So in this case, what's the time here? I mean, they're all going to be 01 access time for all the... And then the space we're using here, well, depending how many times we insert into the stack, but ON space as well then. So if you have 5 elements, maybe they'll all push all 5. That's it for today. I hope you guys enjoyed the stream. And if you want me to do more problems or certain ones, leave a comment and I'll get on that. Happy Saturday.